Okay, let's take a look at this problem about average rate of change of polynomials. So here we have a function, g of t, and just like you saw in the videos on the Khan Academy, you want to think of this like delta y over delta x. Although we're not using just x's and y's here. Notation-wise, this is more like what you're seeing here is delta g, or delta g of t over delta t. In other words, just like we calculated slope back in the day, you're finding the difference in heights, the difference in y values, the height of the function, and dividing that by the difference in x values, I guess in this case t values. Okay, so I know I'm kind of calling up a little old-fashioned notation or terminology, but that's what average rate of change over an interval is doing. It's just that with lines, it was easy to see because the slope of a line is so consistent. So we're going to use this function g and these t values. In fact, this lower, the lesser of the two, is your t sub 1, and the bigger one is t sub 2. So we can really amend this idea of slope or average rate of change. Even though we're not dealing with a linear function anymore, we can use the same mathematics to answer the question. So on the bottom, we are going to have this t sub 2 minus t sub 1, just like we did, find the difference in x's, we could find the difference in t's. And that's going to be easy to calculate here. That's the easy part, at least, is 5 minus negative 4. Okay, so right away we can calculate what our divisor is. That'll be positive 9. Now the rest of it, in fact I'm going to change colors for this part, is a little bit more involved. And this might be where a lot of people's errors are kind of getting out of control, having to do with order of operations. Every once in a while this can be a thing. So look at the structure here. Okay, we've got a quantity being squared and then a negative being applied to that result. Think of that as a phantom 1. So negative phantom 1 times the quantity, and again, our first, I'm getting ahead of myself here. The beauty of these problems being done on the computer is I can fix this little typo, move this over here, and let me just kind of outline what we're going to do. Well, I think blue is a good idea. So we're going to do g of, what were we saying? So it was y2 minus y1, so it's going to be g of t sub 2, okay, minus, and I am going to go color changer mode here, and then green pen, minus g of t sub 1. All right, so fancy notation. I know I threw some subscript in there, but basically the function at your second t value minus the function evaluated at your first t value, that's like finding the difference in the heights of this function on this interval. All right, back to blue. So we've got, what was it? T sub 2 is 5, okay? So we're going to put that in for t, and in the function here, that's minus 1 inside, squared, and then we have a plus 5, all right? Now, I didn't draw this line big enough. We got a lot going on upstairs there. So, subtract from that, and I'm going to protect this all with a set of parentheses, okay? G of t sub 1. In that case, it's negative 4 for that first t value. So, we go ahead and put that in. We're going to have negative 1 again, kind of a negative phantom 1, out in front of a negative 4 minus 1 quantity squared plus 5. Now I'm feeling for most of you, by clarifying that negative 1 out in front and separate from what's being squared, we may have fixed your error right there. That comes up a lot. But let's run through this. In blue here, 5 minus 1, 4 squared is going to be 16. And then, oh my goodness, 16. Oof. I got to, where'd my eraser go? Getting used to this tablet. Okay, so 16, when you square this part, 5 minus 1. And then apply the negative 1 multiplicatively. So negative 1 times 16. Really, that's just negative 16. We can kind of fast forward this. And don't forget your plus 5. Okay? So plus 5. So that is negative 11. Okay? Now, I know I have that 9 downstairs, so I'm just kind of showing my work for the top stuff. Okay? Carry that 9 as the divisor. Now, on the second wave of this, we're going to subtract everything that we evaluate from the green chunk here. So do some mental math. We got negative 4 minus 1, the PEMDAS, right? Parentheses and exponents. So negative 5 squared, yes, that is 25. Okay, that's like saying negative 5 times itself twice. Okay, negative 1 out in front of that, your phantom negative 1 is waiting and multiplying last. So negative 25 plus 5 is negative 20. But that is all nestled within a subtraction problem. And so we have negative 11 minus negative 20, so that's really plus 20. And you see where we're going here. We are going to have 9 over 9, which is a beautiful answer of exactly 1. So on this interval, okay, this parabola that's opening downwards, quadratic function, has an average rate of change or a slope that connects those two endpoints. Okay, it's kind of like if I were to draw it, it'd be something like, and you'd have a slope of, this is, I'm just really roughly doing it. I don't have my graphing calculator open right now, but it'd be, a slope of 1 over this many up the same amount if you're connecting those two endpoints. I hope that helps. That's just a quick one-take video. All right, thank you for the question.